Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students working on the quadratic relations part of the course. It's video number 3 of the review questions for part 1 of quadratic relations. Whew, that was a mouthful. And in fact, this is factoring video number 2. So here's the review questions we're talking about. And where we left off in the last video was we were looking at question 5, the factoring questions. And we had got to a certain point. I think we did 5J. So let's just pick off where we were. Remember, when you factor, step 1, can I common factor? Always check that first. And common factoring includes looking to see if there's a negative on the first coefficient. If there is, you should factor that negative. Once you've common factored, look and see what you have left over. Is it a difference of squares? Is it a perfect square trinomial? I should learn to fix that. Is it a simple trinomial or a complex trinomial? These are the 4 types we focused on after common factoring. So let's jump ahead and look at K. K for can I factor? Actually, it's not. K for, I don't know. K for nothing. Okay. Now, here we go. So clearly there's an x in each term, so I know I'm going to factor x. Can I also factor the 3 out? Yes, everything there is divisible by 3. So we're going to factor 3x. X squared plus 3x minus 28. So what's left over in the bracket looks like a simple trinomial. So let's see if it factors. Are there 2 numbers that multiply to give negative 28 and add to give 3? So think of all the things that multiply to 28. This is what your brain is doing. Hey, look at that set of numbers. If I had positive 7 and negative 3, sorry, negative 4, positive 7 minus 4 is 3. Positive 7 times negative 4 is negative 28. So I've done factoring. Yay. After K, L. So even though it looks weird, remember step 1, I don't want to see a negative in the first term. So we're going to factor that negative to the front. And then look at what we have left over. I know it looks weird, but again, if you see a binomial, 2 terms that are subtracted, your brain should be trained to think, is this a difference of squares? Yes. 1 squared is 1. So this is a perfect square. And PQ squared is P squared Q squared. So this is also a perfect square. And so to factor a perfect square, it factors into the conjugates of the roots. So 1 plus PQ and then 1 minus PQ. Again, factoring a difference of squares is supposed to be easy. It is easy. You just have to look for it and remember that it turns into the conjugates of the roots. LM is next. Let's see what we have. So first of all, I see that there's definitely an x in each term, and each of these is divisible by 5. So I'm going to factor 5x, and let's see what that leaves me with. So there's my common factor of 5x, and what's left over is a simple trinomial. In fact, I think we just did something like this. 2 numbers that multiply to negative 28 and add to 3 are positive 7 and negative 4. Next question, N. So, can I common factor? No. But again, you should see a negative sign, perfect square, perfect square. So remember that x squared is x to the 4, and 4 squared is 16. So this is a perfect square, and this is a perfect square. So we're going to be able to factor into x squared plus 4 and x squared minus 4. So again, X squared goes in front, 4 goes in the back, and we have the conjugates, the positive and the negative. Now, look at the screen for a minute. I'm just going to let you look while I do a little bit of this. Notice something? Notice something now? That's also a difference of squares. So don't stop. Always check what's left over in the brackets and keep factoring if it's possible to keep factoring. Where's my pens? Found them. Okay. So there's no such thing as the sum of squares. So x squared plus 4 does not factor. But this and this are perfect squares subtracted. So it would factor like this. Classic question. Let's put a nice yellow star. Classic math teacher question right here. Ooh, you only got part of the marks because you stopped. So don't let math teachers fool you. You're better than that. O is next. 7x squared. So now, I know I can't common factor because the only thing that even divides 7 is 7, and 44 is not a multiple of 7. So I'm going to have to try multiplying or factoring by decomposition. So I need two numbers that multiply to negative 308 and add to negative 73. So this is definitely an opportunity to break it down. 1 and 308. 2, 308 divided by 2 is 154. 3 doesn't work. 4 is 77. Before I go any further, if I made this negative and this positive, would I get negative 73? Yes, I would. So I'm not going to go any further. Yay. So decompose that middle term into positive 4x, negative 77x. And now we're going to factor by grouping these two together and these two together. So the only thing in common between 7x squared and 4x is x. And here, obviously I'm going to factor negative because they're both negative, and I can factor out 11. And that looks like it was the right thing to do because I have that bracket in common. And when I factor that, I'm left with x minus 11. Okay, again, some of you are doing this mentally. Some of you are doing it on paper. It doesn't matter how you do it as long as you can find the answers if they exist. Next question is P. So clearly I can't common factor. There's nothing in common between 3 and 2. So we're going to try decomposition. I need two numbers that multiply to negative 60 that add to 2. So let's think about all the things that multiply to 60. 4 and 15, 5 and 12, 6 and 10, 9 doesn't work, 7 doesn't work. Okay, there it is. Now, if I make one of them negative, this is either 59 or negative 59. This is either 28 or negative 28, 17 or negative 17, 11 or negative 11, 7 or negative 7, 4 or negative 4. There's no way of creating 2 out of these pairs of numbers. That means there's no factoring available. Does not factor. Let's move on. Q. 6 minus 11 x plus 4x squared. So I'm going to try to factor this without turning it around. So I can't common factor because 11's prime, and these are not divisible by 11. So I need two numbers that multiply to 24 and add to negative 11. Aha! Negative 3 and negative 8. So decompose 6 minus 3x minus 8x plus 4, oops, x squared, common factor, common factor. Now here, I'm going to factor 4x, and because of that sign, I'm actually going to factor negative 4x. Oops, I don't want that x there. So I'm factoring negative 4x. So I factored negative 4x, all that's left there is 2. Here I need a negative, negative times a negative is a positive, and an x, and that's good because my brackets match. And there's my answer. If you had started this question by rearranging it, you would have this. And that would be fine too. Just, I'll take the answer I was given. What's left? Okay, so now we're starting to fall off the page here. So that was number Q. So I guess we're going to do R. Okay, R. Ooh, look at this question. Now, I know some of you might be thinking, expand this binomial, collect like terms, and then factor. The problem is that expand is the exact opposite of factor. And normally, if I ask you to factor, you shouldn't try expanding. So what else can we do in this question? Well, you should notice, I've lost my pens. What you should notice is that there's a minus sign right here. And then you have 144, which is 12 times 12. And then you have this, which is obviously a perfect square because it's written as a square. So this is actually a difference of squares. So 12 plus this other thing and 12 minus this other thing. So the way, again, what I'm thinking is, I'll use this, it's 12 squared minus brackets squared. So the 12 goes in the front, the bracket goes in the back. Now, I wouldn't consider myself finished because if I see 12 plus x plus 3, I'm going to want to do 12 plus x is 15. And here, 12 minus x minus 3, so I would write that as 12 minus 3, 9 minus x. So there, I factored it quickly because I noticed it was a difference of squares. So let's say you didn't notice that it was a difference of squares. Okay, let's try it again. Where we don't notice it's a difference of squares. So what we're going to do, aha. So we're going to now do that thing that I know some of you wanted to do, which was to expand, collect like terms, and then factor. So let's expand that binomial. So square the first, double the product, square the last. So it's 144 minus x squared minus 6x minus 9. Oops, I don't need the bracket at the end. Okay. Then it would become 144, take away 9. Let's rearrange. Do 144 minus 9 is positive 135, and then I'm going to factor out the negative. And then I need to find two numbers that multiply to negative 135 and add to 6. Let's see, what multiplies to 135? 5 and 27, that's not going to work. 15 and 9. So I could say plus 15 minus 9. And what you'll notice is this is basically the same answer we had before, but now I factored a negative to the front and rearranged these the other way. Same thing, just as many marks. It just took me a little longer. Okay, so where are we? Almost done factoring. Let's look at question S. So can I common factor? No, 16 is divisible by 2, 4, 8. 16, 27 is divisible by 3, 9, 27. Ooh, so that means, oh dear, I need to find a number that, two numbers that multiply to something crazy. Negative 432, and that add to negative 66. Okay, 1 and 432, 2 and 216. Let's see if 3 works. 3 and 144. 4 and 108. 5 won't work. 6. Ooh, what if it's 6 and 11? Ooh, 6 and 72. Oh, 6 and 72. Interesting. Positive 6 minus 72. Bingo. Those are the two numbers. So decompose. That middle term becomes positive 6x minus 72x. Common factor the first two. Common factor the second two. Factor the bracket that's in common. And I'm left with 2x minus 9 as my other factor. So don't get intimidated by big numbers. We have a method for checking all possible factors. Don't start just randomly guessing numbers. Process is important. One more question, and then we're done number 5. So the final question says this. Let's factor 5p squared plus 30p plus 45. Common factor 5. What's in the bracket here is a perfect square trinomial. Perfect square, p and 3. If you multiply them together, you get 3p. If you double that, do you get 6p? Yes, indeed. So this factors quickly like this. Done. Whew, long video, but lots of help with factoring. I'll see you in video 4.